in which cases is related to our lab experiment tomorrow. So we have a gun, spring gun, shooting at an angle. So that spring gun. So we like to using this as a coordinate. Means it was 0, 0. So it's shooting the ball and then go all the way and drop. So during this projectile, there's a flight, and they go down here. At any point of x, y, what happened to it? So we like to develop a basic form from this. First, we have to have important information in here. What part of the equation is useful for us is from the x direction. We have x f, or precisely that is equal to x. That equal to xi plus vxi t plus 1/2 ax t squared. So this is along x direction. We like to express the coordinate x and y is one of them is dependent variable. That means at any point in this travel, this is the x-axis and this is the y-axis. At any point in here, we can express the y in terms of x. How can we do it? So first of all, the x equal to this. Assuming xi equals 0, we would like to, the coordinate system is determined by us. So we can shift around for our convenience for reasonable cases. This is the xi equals 0, and then the ax equals 0. Okay, so in these cases, then this is an angle theta. So that in these cases, then we like to have x is equal to 0 plus v, initial velocity, times cosine theta times t. So this is expressed in x. So now along y direction, we are going to using the same thing. Y sub f is equal to y sub I plus v y sub I times t plus 1/2 ay t squared. Okay, from here, you know x is equal to v sub I cosine theta times t. So t is equal to x divided by v sub I cosine theta. This is very important information. That means we want to express y in terms of x without t there. So this is replace the t in the next equation. Now y sub I is equal to 0, and then v sub yi equal to v sub I sine theta, and then t equal to that, and then a sub y equal to minus g. Chinatown. We Cantonese have a very bad habit. That is y equal to 0, and then this is a v sub I times sine theta minus 1/2 g t squared. Now you want to, there's a t here. You want to substitute t in terms here, and you will get y equal to v sub I sine theta times t is equal to x v sub I cosine theta. V sub I cancel. Minus 2 t squared equals to v sub I cosine square theta. And then you have a v sub I squared. And then you have x here, x squared here. And then you have g here. So finally you have equation y equal to tangent theta of x minus 2v sub I squared cosine square theta g to the x squared. That means that this equation going to do a magic for you tomorrow. Okay, so we developed this equation ahead of time so that you think about it. So what is significant of this equation? Significant is at any time related with x and y. That means x is independent variable, y is dependent variable. If you know what is unknown in here, x, y, what's the other one? Theta. X and y theta. You don't know, right? If you know theta, then you know x, then you can find out y. Okay, so this is a very good examples. And ladies and gentlemen, that is what you need to know to solve problem 61. That's what you need to know to solve the problem of 57. If the teacher let you know, hey, this is have to be equip you for solving this problem. Again, this is the problem. This is type of thing is related with the number 51 or maybe 45. So the teacher let you know that this is the basic you have to know to solving those homework problems. If I don't tell you that, then you probably struggle for hours and hours and hours. Okay? I did it. I did hours and hours yesterday. So that is 3.4. So now I go into the section 3.5. 3.5 or 3.4 is related with uniform circular motion. 3.4 and 3.5 is related with the circular motion. There's a lot of motion is related with the circular motion. Okay, 3.4 and 3.5 called circular motion. Circular motion. Now we got to go into yes, 24 minutes. Okay. Circular motion is a very important motion. A lot of things you do, you don't think you are doing circular motion. When you're turning left, circular motion. When you're turning right, it's circular motion. Of course, when you're doing this circular motion. So circular motion is, in order to have a circular motion, the object must have a tangential velocity called v. And then must have some force push it down to the center. And then in here, push it down. Because the velocity travel in here keep changing directions. So this is very important. So this is F sub c. In order to maintain the circular motion, there must have a centripetal force called centripetal force. This centripetal force is real. That is equal to mv squared divided by this radius is r. we will do this experiment next week in a very short experiment. But when we do the other experiment, the complicated one, and then you become a special project on your own doing it. So centripetal force is real. This really happens. If you do this circulating thing and then you cut off the cord, the centripetal force release it, then this object will go this direction. So a lot of people say there's another force called come here. Outward is called centrifugal force. Centrifugal force is not real. Remember, centrifugal force is not there. It's a fictitious force. So this is the key for you to learn. This is not real. Centrifugal force, not real. We're using that just for certain type of explanation, but it's not there. So this is an MCAT. Sometimes it will ask you to answer this kind of questions. So today we start at 3.5 section for the lecture portion. And then tomorrow we will pick up from 3.6 and go on to chapter 4. So tomorrow is Thursday, we probably will finish chapter 4. I'm sorry, that means that you have 4 chapters of homework to be due next week. Okay, that's what when you're taking these classes in the compressed fashion, you have no life. Okay, if you still have a life, you must very good doing what you're supposed to. Okay, that's it.